and welcome to another episode of FooBar. In this episode, we are going to finally be talking about Alexa skills. If you want to know more about serverless, cloud computing, or software engineer practices in general, subscribe to my channel in the red button below. I post 2 videos every week. So let's get started! This is another episode in the series This Is Not a Podcast, and this week I'm with Sohan. I will not try his surname, it's too complicated, and you will see me fail in the video trying. And he is a developer advocate for AWS, he works in my team, and he will come and talk to us about Alexa skills and how you can build a skill and what is the difference between an Alexa skill and Lambda and Lex, and how you can leverage everything you know about building serverless applications into building Alexa skills. So this is a session packed with information and lots of demos. So let's go to it. Hello and welcome to this episode. With me I have Sohan Maheshwar, and I totally destroyed his surname, I think. But welcome, Sohan, to the show. Can you pronounce your surname correctly for me?
Yeah. First of all, thanks, Marcia, for having me. My name is Sohan Maheshwar. You came close, but that's good. Yeah.
Yes. You're a developer advocate for AWS. And what is your story?
Well, I've been working for Amazon for 2.5 years. I used to work in the Alexa team earlier back in India, and now I'm based out of Amsterdam, where I work in the Benelux region as a developer advocate for AWS. And yeah, it's been fun so far.
And that's why we are going to talk about Alexa skills. We have one of the experts here to tell us everything about it. But you told me when we were preparing this that you are a frisbee freak, that you love to play frisbee, and you even play in the India team for frisbee.
Yes. This was a while back. So I've been playing frisbee at a club level for about 10 years. This is Ultimate Frisbee. It's a 7-a-side game. A lot of running, a lot of jumping. Yeah. And in 2015 and 2016, I played for the India team. I played in the World Championships in London as well, which was it was a good experience. So something I'll keep with me for a while. That's
crazy, because I was never imagining that frisbee was a competitional sport, that you can have like a world champions of it. But well, if people play Quidditch in a world champion frisbee, why not?
It's actually pretty big. Yeah, I think on the World Championships there were like 40 odd countries that came. It was this huge thing. It was a lot of fun.
Nice. So, as I said, we are going to talk about Alexa skills. That's something I never cover in this YouTube channel, but I think it's very close to serverless. It's something I think from the AWS certifications is one of the most serverless ones from the specialist perspective, and everything that you will be talking will resonate very closely to the audience of this channel. But before getting started with that, what Alexa skills is, I think you mentioned that a good starting point for this is what is voice design, because it's a very different way to design applications of what we are used to making applications for mobile phones or web apps. So maybe we can talk about that first.
Yeah, sure, Marcia. And I think this is that's a good segue, because I think this is the ideal way to start off a conversation about Alexa. Alexa basically is a voice user interface. So you're essentially using your voice to communicate with the machine. Now, you might think like, hey, why do we really need this? We have like a mouse and a keyboard. I'm so used to this sort of interface. But if you think about it, all the interfaces we have used so far in our lives when we are interacting with personal computing are not things that are natural to human beings, right? We use pointers and clickers and like touch screens. These are interactions we have learned over time. It's not something that has come naturally to us, but speaking comes naturally to all of us. Listening comes naturally to all of us. And I think if you've read a lot of science fiction, like especially in the 1930s, 40s, all of them had voice-controlled computers.
You don't need science fiction. I have an Alexa at home, and my kid is the master of it. Alexa, play Happy Birthday. Alexa, Netflix. Alexa. It's like she cannot read, she cannot write, but she can speak, and she learned the keywords that trigger her. So it's like
Yeah, kids love Alexa because I think they can say stuff to it, and they can keep saying the same stuff to it, and Alexa won't get irritated or annoyed. But yeah, so it is this new way of sort of communicating with machines. And because it's a new way of communicating with machines, the old way of sort of designing doesn't really apply to, building like an interface for voice. Like, let me ask you a question, Marcia. If you were to build, say, a mobile app or a website, you would have like a front end and a back end. And typically we would start with, hey, let me, sketch this up. Let me draw a flow chart of how, if I click this, this happens. If I do this, this happens. That doesn't really sort of work on voice because, people can say the same thing in so many different ways. And there's no fixed way of doing something. Like if I go to Amazon.com and, if I want to buy a product, there are like a certain bunch of clicks I can do to buy a product. And outside of the menus and the buttons that Amazon provides me, I can't do much else. But when it comes to voice, I can say anything I want. Yeah. And it's up to Alexa or the skill that you build to sort of understand and, sort of help the user achieve what they want.
And I think also when you're designing a website, you're limited to the options that are in the website in the sense that the designer will need to think, okay, and maybe they put them in menus and they organize it. But with voice, you have an idea of what you want to do when you get to that app. If we talk about Amazon, I want to buy toilet paper. So you say, I want to buy toilet paper. You don't need to go to search. You don't need to click there. You need to pick the category and do all these kind of things. But it's more intuitive. And I think that's very difficult to model for that.
Yeah, exactly. That you hit the nail on the head there, Marcia. So it makes it a lot more intuitive. It makes it a lot more easy. There are no menus as such, right? No one will use a voice interface and say, hey, go to electronic applications, go to mobile phones, go to Apple, go to iPhone.
The best examples is when you call customer service and they start, press 1 for blah, blah, blah. Press 2 for blah, blah, blah. And there is a list of 27 numbers and it's like, what was my number? 5, 3, I don't remember. Yeah. Like menus in voice is very hard.
Yeah, exactly. Again, you're hitting the nail on the head because we don't want those IVR, interactive voice response type messages on Alexa. You want people to be able to speak naturally because I think that is the sort of conversational experience that you really want. So I think designing for that is slightly different again from designing, like a website or an app or any sort of interface that we have designed so far earlier.
So you need to have like a voice designer in your team or something like that.
Yeah, it's funny you say that because post this whole advent of chatbots and voice interfaces, there is this new job description that's opened up, which is like a conversational designer or like a UI designer, which didn't exist before. Right? And it's so interesting that as technology evolves, all these new jobs open up where people are specializing in designing for voice or designing for conversation, where you have like a script writer or a conversational designer who does this.
Yeah, that's very interesting. And I know I was thinking about it when you were mentioning it. Like, yes, we need a voice designer. It's just like, and so then Alexa skill, it's an Alexa. What is kind of the difference? Where is the box? What is the name? Like the right names for everything? Because I say Alexa as a general thing, but I'm pretty sure everything has their own. It's like Lambda. It's Lambda functions, the Lambda platform. So
that's a good question. So essentially, Alexa is the cloud-based voice service that powers the devices that you have in your home. So you might have an Echo or an Echo Dot or an Echo Plus, or maybe it's on your phone. So the cloud service that really powers all these devices is called Alexa, which is fine. But people say, I am speaking. It is, But people say, hey, I'm speaking to an Alexa device, which is completely fine.
And you could integrate Alexa in devices that you build if you want then.
Absolutely, You can build it, you can use it in your app, in your mobile phone. And in fact, there are even third-party providers. There's JBL, there's Harman, there's Bose. All of them have Alexa in their speakers, in their headsets. I even saw in CES earlier this year, there was a toilet seat that was Alexa enabled. Don't ask me the details, I don't know. But someone's actually gone ahead and built something like that. So
why not?
Why not?
Can you warm my toilet seat? The first experience with those Japanese toilets is always daunting. So if I could talk to that, it would be way more easier than to find what is the right button for the right thing.
I think a video on the Japanese toilets would be pretty. Those are pretty cool though. That is cutting edge technology. But like I was saying, there is Alexa, there is Echo. The main thing is like there are apps on your mobile phone and how there's a Play Store and an App Store. There is something called a skill on Alexa. I think of it as a voice app and anyone can build a skill. It's completely free to do so. And you can build the skill and upload your skill to the skill store where other people can use it. So I can maybe build like a skill, and Marcia, if you think, hey, this is like a nice thing that I might be able to use, you can enable it and you can use that skill. So that is how skills work on Alexa.
And one of my favorite Alexa skills are these games that are like audiobooks that you can play. Like if it's like I don't know if when you were little you had this choose your own adventures book,
yes.
But they are kind of like that, and I think they're so amazing because you're like listening to a story and then you can do things, and I think that's kind of a great example, at least for me, from an Alexa skill, because it's something I really enjoy and I would love more of that.
Yeah. Those are very popular on Alexa, very, like you said, choose your own adventure. And the skill makers try very hard to create like this immersive sort of environment. So you have sound effects and you have different voices and, it's really cool.
It's like an audiobook, but with,
it is,
with adventure.
Yeah.
It's cool.
Exactly, yeah. And I think it works because you're doing the imagination part, right? So you're imagining the monster and a door and like a creaking noise, and it's leading you in that story. So it's very cool.
Yeah, I think, I don't know, one thing, like putting voice on everything might be not the right choice, but if you find the right things that you can do with voice and things that are natural, like shopping or notes or things like that, those are very natural because you're in your kitchen and say, I need to buy soap, and Alexa, add soap to the list, or something like that. But then also storytelling and things that you can imagine and things like that are really a great fit for this type of voice kind of interfaces. They are in your head all the time, so.
That is true. In fact, a lot of people use Alexa in the kitchen, mainly because your hands are always busy, cutting, cleaning, cooking, and it's just so easy to have that conversation, like you said.
I really like it there. It's one of the places I use the most, this, put a timer or basic things, but they're super handy when you have a kid in one hand and then chopping with the other, and then things are burning.
Yeah.
Voice is something you always have free somehow. So let's talk a little bit about the basic concepts inside an Alexa skills. What do we need to know to get started building Alexa?
Yeah. So very briefly, there are three main things that happen in the Alexa cloud when you're building a skill. The first one is speech recognition. Again, it's taken care of by the Alexa cloud, where your speech is converted to text, right? And it does so with some context. Does so accurately, of course. And then once it's converted to text is when the key thing happens, which is natural language understanding, or NLU. Now, Masi, I know you have a very, very popular Lex video out there where you probably explain some of these concepts in detail, but it's the same principle where a computer needs to understand what a user is saying. So if I say something like, what's the weather? You need to understand what the action the user really wants to do. Yeah, and the reason we have this inner conversational interface from like Alexa, all of it, is unlike a traditional user interface, there are multiple ways of saying the same thing, right? So like, for instance, Marcia, you might say, what's the weather? But I might say something like, is it hot outside? Because I'm in Amsterdam, I might say, is it raining outside? Because it's always raining over here. Or I could even say something like, do I need an umbrella today? Or do I need a coat today? Right? Just different ways of asking the same thing.
Exactly.
Yeah. So these sentences that the user says is called an utterance. And what the natural language understanding algorithm does is it breaks down a single utterance into two things. It breaks it down into an intent, which is like the action that the user wants to do. So in this example, it would be the user wants to find the weather. Exactly. Maybe the user says, I want to book a cab, I want to hire a taxi. The action would be book a cab.
Exactly.
And it breaks it down into an intent and another thing called a slot value. Think of a slot as any sort of variable within a user's utterance. So for instance, I might say, what's the weather in Amsterdam? And Marcia might say, what's the weather in like Helsinki? Someone might say,
it's like a field in a verbose form.
Exactly, yeah, exactly. So something that can change within that utterance. And that is a slot value. And utterances can have multiple slot values. Like I can say, help me find an Italian restaurant in Paris. Exactly. And you have a type of cuisine and a city in which you want to find it, which are two slot values. So that's what the natural language understanding algorithm does. Cool. So essentially, the Alexa cloud is taking care of these two things. And it sends what the intent and the slots are to your service. And typically, that service is a Lambda function. Think of it as your backend. You can do what you want. You can hit an API, you can hit a database, I don't need to tell you all that. You have to send some text response back, and the Alexa cloud takes care of converting that text to speech. And it does so using something called SSML, or Speech Synthesis Markup Language.
Okay.
This is a general technology. It's not Amazon or Alexa specific, but it essentially enables your voice to sound a lot more human-like and conversational. Yeah, big difference between a computer reading out words versus us talking right now. Like I can talk really softly like this, or I can shout like this, and I can change my tone and inflection. So SSML allows you to do some of those things to make your skill and make your experience more conversational.
Exactly. I have seen some of the examples, at least from Poly, that is the service that reads things out from AWS, and there is this type of neural voice, and you really, when they're really, like, it's reading the text, you don't know if it's a real person. If somebody will call me on the phone and start speaking like that, I will not recognize. Unless I start asking questions, and maybe then he doesn't understand my strong accent, but maybe that happens in reality as well. So
I think you're giving phone call scammers ideas now, Marcia, by automating some of these things.
But it's pretty crazy how the technology has evolved. And what about, because I know Poly, I know Lex, I know Transcribe, and all these services from AWS that are basically, are the ones feeding this Alexa? Is the same services that are used behind?
Yeah, the infrastructure for all of those services that you described are the same that are used by Alexa. So Transcribe, Poly, and Lex essentially. And you can integrate a lot of the Poly voices into Alexa. So like you said, you're building a game like a choose your own adventure type game, and you have different characters. Instead of just having Alexa's, same voice, you can add like different characters, different accents, and make it like a lot more engaging and fun.
And you can do it multi-language? That's one of the questions I get all the time with Lex, like how it can work for multi-language. So with Alexa, it works.
So when it comes to understanding, it's a little more complicated, right? Where you speak with a mixture of, say, English and Spanish or English and Hindi. So there is a multilingual mode, and they are right now it's limited to English Spanish and English Hindi for mostly in India. So I can't switch between, say, Japanese and Spanish at the same time, and Alexa might not understand that. But there is a multilingual mode. When it comes to saying things out, you can say any language. So you can have like a French voice talking in English. You can have a French voice talking in French. Outputs is fine, but understanding, it's limited to those two.
Yeah, that's something that I think it's a problem for all them, like this natural language processing, that accents and words and locales of your voice, because it's not the same, like an English person speaking English and a Spanish person speaking Spanish, a Latin American person speaking English. It's just like all the ways that you can pronounce and how you can say. It's a huge challenge for everybody, like from building those services. So I understand when they don't understand me. It's just like, okay, whatever. I will repeat it over and over again. Maybe one day we're trying that.
No, it is true. It is a very complex problem to solve, right? I think as humans, this thing comes naturally to us, where we're able to understand context a lot better. With computers, it's still taking time, but it's evolving and it's getting better by the day.
Yeah, and also in a way, humans get better at talking to computers, because sometimes if you give like Alexa to your mom or something, they will be like trying to talk as it was a person. But then, for example, my kid never thought Alexa was a person. She was replicating the way I was talking to it. So she's just really commanding the machine. She really doesn't like no empathy whatsoever with the thing. She's like, Alexa, do that. And Alexa goes and So it's like, it's just a matter of how the human also is trying to talk to them.
That's an interesting point, because I think whereas kids 10 years back were sort of growing up on smartphones, and 2-year-olds can use YouTube like easily. And wheels on the bus go round and round. But now kids are growing up with voice interfaces like Alexa, and that will become second nature to them.
Exactly.
So that's where we're headed to.
Yeah, I have a friend that has a kid, and when it was many years ago, she was swiping on magazines. So I imagine the future kids will be talking to random spaces in the air, like Alexa. No, there is no Xa here. Oh,
You'll be surprised, but I've seen kids do that already.
Oh
so.
no,
Yeah.
that's so funny. Yeah, because they get so used to that. Everybody's listening to all the time. So yeah. So maybe we can go now a little bit onto the parts of dialogue management and how you can create a skill and how everything looks from the Alexa interface. One thing I think is important to remark that I didn't know before joining AWS, that Alexa is not inside the AWS console. So if you want to get started with Alexa, what you need to do?
Yeah, so it's very simple. You have to just go to developer.amazon.com and sign up for an account.
All the links are here. You can do that.
Yeah, yeah. All the links in the description below, and yeah, it's completely free to do so. That's the best part. No credit card required.
Oh, no
prices,
credit card.
nothing. Yeah. The great thing is, and I'll show you an example later. You can choose to use a Lambda instance on your AWS to build your backend, but developer.amazon.com also gives you a Lambda function within that browser, within like each skill. So you don't even have to have your own backend and your own AWS account to get started. So to get started, it's just really simple. It takes you like a minute to sign up and you can just start building right away.
Wow, that's super cool that you don't need to have a credit card to get started, because that's always a thing that people are a little bit afraid when they are registering for the AWS account. It's like, oh, I need to put my credit card. And with this, they don't need to. So that's pretty cool. And then when you're in, I don't know, can you show us?
Yes, let's do it. So I'm going to share my screen and we will build something. All right, so like I said, all you have to do is hit developer.amazon.com. This is how it looks. I've already signed up for an account, of course, but you can do that. It takes a minute. And I click on the Alexa button to create a skill. I can click on the Create Alexa Skills button. And yeah, you can see a console right here, which essentially, if you have not created a skill before, it will be empty. I've just created a bunch of test skills, as you can see. I'm just going to hit the Create Skill button. And what we're going to do is build a very, very simple Hello World type program. I think this is important because you sort of need to know the different working parts of a skill, again, because it's a little different. Yeah, and I'm going to take the example of something called Cakewalk, which is a simple skill. It's a tutorial actually that the Alexa team built back when I was in the team as well, which sort of, it's a very step-by-step tutorial on how to build a simple skill. It's very simple. All it does is it asks the user for their birthday. And it says, okay, X number of days left for your birthday, right? And we'll do maybe a step-by-step way of, adding complexities and stuff like that.
Okay.
So let's call it Cakewalk. It's also a nice name. It's the name of a dance from the early 1900s.
Oh, really?
Yeah, I don't know why I give all these random trivia.
You like trivia.
Yes, I do. Okay, so here's the thing, right? These are the language supported by Alexa. You can see German, Japanese, French, etc.
So you need to decide on one.
Yes, you can add multiple as well. You need to decide on one to start off. And you can also see different models for English itself. And the reason is I'm choosing English US, but the reason is in different regions that we launch, Alexa, people speak English differently in the US versus India versus Canada. Right? And each language model is sort of customized to that region. So Alexa is trained to understand that accent as well as speak in that local accent.
And
so
also
for now,
the words.
Yeah, the words.
It's not only accent.
Yeah, a lot of context changes in different countries. So that's the change we'll make as well.
I have so many examples in Spanish and they are very dirty, so I will not say any out loud. But
maybe once this call is done,
they can ask me in the comments. I will tell them. I don't want my video to get demonetized.
All right. So we are choosing custom for the front end of our skill. You don't have to worry too much about this. Unless you're doing like something that has a lot of content, like a blog or a podcast, you choose flash briefing. And the other models are self-explanatory. But
so you can put a podcast on Alexa. I never thought about that. Interesting.
Yeah. Yeah. And maybe if you want to say, if you have a podcast, Marcia, and you want an Alexa skill for that podcast, you can actually build one using this flash briefing option right here. And all you have to do is just give like an RSS link and, it takes care of the rest.
Wow.
But for all other sort of skills, you typically use the custom model. Now, here comes the interesting part, which is how do you provision a backend for your skill? Now, again, I'm sure there are a lot of heavy AWS users on this channel watching this video, and you can absolutely use a Lambda function in your AWS account to do so, right? In fact, that is what we recommend. And if you want to use your own backend as well, you're completely free to do so. But if you want to get started, maybe build your first skill, I really recommend using something we call Alexa hosted, which, like I said, is a Lambda function that is given to you for the backend for your skill.
Nice.
And it comes with like 5 GB media storage and things like that, and it's free for a year, so you don't have to worry about it.
Nice.
And we have SDKs in Node.js, Python, and Java, but I'm going to choose Node.js for today, if you don't mind. Yeah.
Yes, I don't mind. If you choose this in Java, I don't know what to do. It's been like 4 years that I don't do Java.
Do you know James Gosling, the creator of Java, is our colleague, Marcia? He works for Amazon right now, yeah.
I should stalk him.
I didn't know that until recently. Yeah, I stalked him internally a little bit. I hope he doesn't see this. Anyway, so there are some templates that you can use to get started. I'm going to use a Hello World template, of course.
Oh, there is the cakewalk template there for you.
Yeah, there is a cakewalk, but we'll go step by step so that you sort of understand how everything works together.
But if people want to get this, they can go through there if they want.
Oh yeah, and then there are a bunch of other templates for, to get started with the game and things like that as well.
Nice.
So what's happening right now is actually instantiating a Lambda function and giving it to you as a backend for your skill to use. There's also a simulator in the browser, so you don't even need a device to test it out.
Okay.
But if you have a device, and this is a pretty cool pro tip, if you have a device, make sure you sign up on the device and on developer.amazon.com with the same ID. And you don't need to deploy the skill to the device then, right? As soon as you build, you just say like open Cakewalk and it's ready for you on the device, which is pretty cool. Yeah.
That's really cool. So you don't need to do any magic.
Yes. Yeah. There's no deployment, nothing. It's ready for you straight away.
So that's how it looks.
Yes. This is the dashboard, and this is what you basically need to get familiar with. Now I'll just take you through a few of the options. What you see on the screen. What you see here in this menu think of it as the phases of building a skill. So first is you build the front end of your skill. You code the back end of your skill, then you sort of put the two together and you test it out using the simulator. You can then go ahead and like we said earlier, you can publish your skill to the skill store, which means, giving a title, giving a logo, giving like a privacy policy, and that can be done, in the distribution phase. Before it goes live, there is a small certification process that happens, just to make sure that your skill does what you claim it does, and it works and it doesn't error out and things like that. And that's what you would see in the certification tab.
And that certification is like something Amazon does for all the skills that get published?
Yes. Yeah. Amazon does. It typically takes about 2 to 5 working days.
So like Apple Store when you publish a...
Exactly like that. Yeah, exactly like that. There are just few, tests done to see if your skill works fine. And of course, once your skill is live, you can get analytics about how users are using their skill.
But that's good because then it meant, it's really nice because that means that then all the skills in the store are kind of working and they do what they do. So it's kind of a safe store for people to pick things from. They don't need to worry.
Exactly. Yeah.
That's
exactly
really cool.
right. So there is some sort of quality check that happens just to make sure the skills work.
Exactly.
And there are checks to see whether there's like any adult content or any copyrighted content and things like that as well. Cool. So should we start building?
Yes, let's build.
Okay, let's go. Now, Marcia, easy question for you. How do you open an app on your phone?
I tap on the icon or...
Yeah, exactly, right? Yeah, so you tap on an icon. Similarly, if you have to go to a website, you type out the address of the website. Now, remember, this is like a voice-first paradigm. There is no keyboard. Typically, there are no screens to tap as well. So how do you open a skill? Like, how do you start interacting with like a skill that someone's built? Now, what Alexa or what each skill has is something called an invocation name, and that's what you see here.
Yeah.
And this is what a user has to say to get started with the skill. Think of it as saying this to get into the skill. So if a user says something like open Cakewalk, which is the skill I'm building, they will then start interacting with my skill. So they will be within that skill experience basically.
And those names need to be unique through the whole word, or how they work?
Yeah, so they don't have to be unique, which is a question actually we get asked quite a bit. So what happens is before you use a skill, or if you use a skill, you have to enable it on the skill store. So say for some reason, there are like about 5,000 cat fact skills, maybe not 5,000, but a lot of cat fact skills on the skill store.
Everybody loves cats.
Yeah, and everyone seemingly loves cat facts as well. So if I go and enable one of them, and if I say open cat facts, that's the one that would open. Now, there is also something called invocation via voice, where I can just say out loud, enable cat facts, and Alexa will automatically looking at some internal algorithms, like, like how popular a skill is, the ratings, reviews, would pick up maybe the most popular one and something relevant to you and enable that as well. So there is some, AI/ML going on there as well.
Nice. So if there can be as many as we want cakewalks. It's not like S3 buckets that we need to put a horrible name to them, and then we need to say, Alexa, open Marcia-FooBar- my blah 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 3459x27 cakewalk.
Yes, exactly that. Yeah, unlike S3 buckets, these can have the same name as well. So you can't do like a domain squatting thing and pick out all the popular things and keep it for yourself. Yeah, if someone builds a more popular, better skill, then that's what will be invoked. Yeah. Cool. So we did that, and now every skill will have an intent, and we discussed this earlier. So for instance, in Cakewalk, you would, like I said, it's a simple skill that asks someone when their birthday is. So we basically have one action in the skill, which is when a user responds with their birthday. Right. So now a user can say that in multiple ways. They can say my birthday is on this day, or I was born on this day.
And one thing at least I think is important to mention, at least when building Lex applications, is that it's always the user starting the conversation. So you always need to design these flows in order to be like the user is the one starting. It's not like Alexa will pop and say, hey, what is your birthday?
Yes.
So that's something, at least I got so many questions in my Lex series, how I can get this starting. No, it doesn't start by itself. You need to trigger it.
Yes. That's really interesting, and thanks for saying that, Marcia, because they are absolutely right. It's always the user has the control of the conversation and always starts the conversation. You will never suddenly hear Alexa saying, hey, when's your birthday? Or, hey, the weather in Amsterdam is so-and-so, unless the user actually asks. And it makes it's a lot more imperative for a voice user interface, because imagine you're in your living room, you're having like a quiet dinner, and suddenly Alexa like, hey, the weather is so-and-so, which is not a good experience. Yeah. So the user always has to start that conversation. And like I was saying, you need an intent. So this is a hello world. I'm just going to close these. Yeah, this is a hello world skill which has one intent, but we're going to delete that, and we're going to create a new intent. Now, you can call your intent anything, but how you name it and the capitalization, the exact spelling matters, because you'll see that later, because we will use that name of the intent to match in our backend. Again, very similar to Lex. All right, so now, cool. So we are going to capture a user's birthday. So we're going to say something like capture birthday intent, and I'm going to create an intent. Now, every intent that's created needs a list of sample utterances that match to the intent. Essentially, put yourself in your user's shoes and say, how would my users really say their birthday? Or if you're building a weather skill, how would my users really ask my skill for the weather? And think of as many examples. The more comprehensive the list of utterances is, the better, and the more wider range of inputs your skill can take. Don't overdo it and add like 5,000 utterances, because then anything your user says will be matched. So be sort of pragmatic about how you actually do this.
And this is also very important, because there is a machine learning behind, but the machine learning needs to get trained with something. So you can put something simple like my birthday is and blah, 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 but then so many things will get out from that training model. So it's a hard thing to decide how to build these intents in a, not adding too much, but as you say, not too many. And it's always very challenging on how people, like, at least I have not tried the birthday thing, but I have tried these examples on booking a holidays, and there's so many ways on how people can ask for kind of hotels and planes and flights and I don't know, rent cars and things like that. One question, is there a place where you can see all the failed intents in your skill? At least Lex has that, and it's pretty nice. Is there something like that in Alexa?
Yeah, so there's a slight difference between how Lex and Alexa treats what the user is saying. All right. So to answer your question, yes, but not in all cases, and I'll tell you why. So with Lex, you always get the full transcription of what the user is saying.
Yeah.
Right. So if a user says, I want to book a hotel on the 19th of May or whatever, the developer will get that entire statement, the transcription. That doesn't happen with Alexa.
Okay.
Because of course, with Alexa, since it is a voice user interface, it could lead to, privacy concerns. And at Amazon, we are of course concerned about a user's privacy. So like in the background, someone might say something which has, personally identifiable information. And if a developer gets access to all of that, it could potentially be, a risk in terms of privacy. So a dev gets only the intents, the slots, and some metadata like, like IDs and things like that.
Okay.
But if say you're being very lazy with building your utterances for your intent, and a lot of your users are saying like one sample phrase and you're not capturing it, I think if more than 10 people say it, and once your skill is live, you will get that as an anonymized thing saying, hey, your users are saying this, but you've clearly not built for it. So, maybe build for it.
Nice.
So it's taken care of that way.
That's good.
So,
yeah.
Yeah. There is a balance between, that privacy and also how you can improve your experience by doing so.
That's really cool. So let's continue.
Yeah. Okay. So I would typically say, my users would say something like, I was born on so-and-so, my birthday is on so-and-so, etc.
So you need to put those little dots?
Oh, no, I was just getting to it. So now the thing is, when it comes to birthday, there are 3 different pieces of information, right? There's the day, the month, and the year. It would be impossible or really tough for someone to write all utterances like my birthday is in August. Or is in July, is in September, and like every possible permutation combinations, which is why you need a slot value. So we're going to create slots.
And then
right
people
away,
can say my birthday is, because you're talking to a machine, on 16 of 07 or something like that. You can.
Yeah.
So not even the month will capture it.
Yes. So you can add these slot values, which are basically variables. So you don't have to enter every possible input. So I can say something like my birthday is on. And how you add a slot over here is again very similar to Alexa. You open up a curly brace. And I'm going to add 3 different slots. So I'm going to add day. Call it date actually. Date. I'm calling it month. And I'm calling it year.
Cool.
All right, or alternately, someone might say something like, I was born on date. And once you've already created a slot, it would show up whenever you just open it. Yeah, so it already shows up right there. So here's where voice design really comes into the picture, because a user could maybe just say something like, I was born on 1st December, right, without mentioning the year. But you actually need every piece of information.
Oh, my birthday is in the 1st of December, that you don't care about the year itself.
Yeah, exactly.
Every year is on the same day.
Yeah, it is the same day. But for the skill specifically, we're building the skill which replies with, hey, X number of days for your, say, 30th birthday, right? And to give that piece of information, you absolutely need the year as well. So now this is where dialogue management comes into the picture, where, you sort of, again, I'm drawing like an analogy to web and mobile, where if you had a form for filling birthday and you had day, month, and year, or date, month, and year, and the user didn't fill one of them, you could, what would you do? You would say error, or you would gray out the submit button so that the user knows there's something wrong. But on voice, you can't do that. You can't say, hey, error. And the user's like, hey, what's happening? Like, I hate this thing. Yeah.
Well, so in the forms, you also hate them when they say error and they don't tell you why.
What exactly? Yeah. So, in a form, you would like put like a red thing around what's not filled. Yeah. In voice, though, you have to be a little more smart. You have to be a little more intuitive. And you have to, what we call, elicit these pieces of information from the user. So this is called slot elicitation, where you are asking the user for these pieces of information. So we're going to do that in a bit. Now, that happens when a user says something like, I was born on, just say, date and month, right? And they're not given the year. Or I was born in, and they just give the year. And this could happen.
Yeah.
A user could, and it's a conversation interface. There's no such thing as an error in a conversation. Remember that. So it's up to you to sort of figure it out. Now, what we've done right now is we have taken each of these slot values and we have said, hey, this is a slot. But right now, Alexa doesn't know that year, in this case, should refer to a year as in 1985, 1989, whatever.
Yeah.
Right? So you can associate every slot with a slot type.
Okay. Yeah, like Lex
so
does. That's good.
Exactly like Lex. So if I was building a weather skill and my slot was city, I could refer it to amazon.city. And there are already data sets. As you can see, there's musician.
Yeah.
What else is there? There's actor, there's airline, there's book. So similarly for year, we can choose 4-digit number maybe and say, okay, 4-digit number. For month, I think there's month. Let's see. Let's use ordinal. And for date, we can just choose date. Day of the week.
And what if for month you put ordinal, but if I say August?
Yeah, it'll absolutely pick it up.
Okay.
So that's not a problem. Yeah. Okay. And essentially you're basically associating each slot with a data set. So you're associating date with potential date. So if someone says I was born on the 40th, you can throw an error saying, hey, that's not really a date that exists and you're making it up. So there is a built-in slot. You can also create your own slot types. So suppose we were building a skill for food, and we specifically wanted to speak about, say, the different Spanish dishes, for example.
Exactly.
We could build our own our own slot type just for that. Or if we were building a skill just for the employees within our organization, we could build a slot type just for that, where the different slot values would be the employees in the organization. So you can create your own slot types as well.
Yeah, that's very handy.
Yeah. So right now we of course we are using inbuilt slots. Now remember when I said we absolutely need these 3 pieces of information to carry forward. So there is something called, like I said, slot elicitation and slot filling, where we say, hey, is this slot required to fulfill the intent? And we say yes. So we are marking it as a required slot. How you have required and optional parameters in
a form.
So you're saying in a form, yeah. So we're saying this is absolutely required. Now again, you can't throw an error, but you can prompt the user if they've forgotten that piece of information. So if a user forgets to give the date in which they were born, you can say something like, what date of the year were you born? And you can add multiple, and Alexa will actually just randomly pick one so that it doesn't come across as monotonous. Or which date were you born in? Please ignore my grammar right now. And you can actually also program what the user might say in response. So the user might actually just reply with the date.
Exactly.
Or something like, I was born
in, or I never know the prepositions.
Yeah, so something like that. And similarly, we can do that for month and year as well. So which month were you born in? And the user will reply with month. Again, I'm keeping the utterances and prompts to a minimum.
Sure. But when you're doing this for real, you need to really think. And as we talked at the beginning, you have to have a designer for voice.
Yeah. All right. So this is what a user would say. So in effect, what we have done is we have marked these slots as required, which means unless a user gives these pieces of information, you can't move forward.
Exactly.
So think of it again, a flowchart doesn't work, but think of it, we call it slightly differently, where you need these pieces of information, and Alexa will keep asking you, and until you give these pieces of information, you won't be able to move forward.
Yeah, it's like a form validation. We all have seen those in the web, and if you don't provide the information, then the form doesn't move forward.
Exactly. And you can also add your own validations as well. So you can create validator rules where you can accept only a set of values, you can reject a set of values, so you can say reject values greater than 2020 because no one's born in the future as of now, or things like that. Yeah. So you can actually do all of that. And that's pretty much it. One thing you want to check.
Can you add Lambda functions to the validation as well?
You'll anyway get these slot values in the backend, and you can process it there in your Lambda function too. Yeah. And so with dialog delegation strategy, we can either choose auto or you can do it manually.
What is this?
Yeah. So remember when I said, we spoke about slot elicitation and things like that. Alexa does all of that for you, right? And that is what auto delegation is. But sometimes some developers want a little more control over how that happens. So then you can disable auto delegation where you do it manually. So in the backend, you're actually, seeing what slots are available, what slots are required, what the user is given, and
Okay.
yeah. It's a little more work, but it gives you a lot more control. But I think it works really well. So I prefer using auto delegation all the time. So this was how we basically built our basic front end. Okay. So I'm just going to, save and you build your model, and this builds the front end of your skill. Yeah. All right. So we've just built that, and I'm going to hit the save and the build model button. And what this does is it builds the front end of the skill. Now remember, this is just the front end of the skill, and we also have to build the back end, which is to handle all of that we have just built now.
I never thought about a voice like a voice app to have a front end and a back end. That is true, it does, but it's just so funny when you think of front end and it's just voice kind of manipulation, and it's just like, oh. Sure, it's the client part.
Yeah. And like I was saying, there is a Lambda function completely within your browser itself. So again, you can choose to use your own Lambda function in your AWS account. It's very simple. All you have to do is scroll down right here, and in endpoint, you just paste your endpoint, which is your ARN from your Lambda function. Right? And of course, I'm sure all of you all know that already, but by default, what you see here is the Lambda function that is given to you for the skill. And like I said, to get started, this is the absolute best thing. And like I also said, there is a simulator in the browser. So we're going to go step by step in the simulator as well, just to show you how this works. Now, this is the backend of your skill, and it'll always come with some pseudocode right there. Now, what you need to know is every intent has its own handler in the backend. So as you can see here, remember we had built a hello world intent in the hello world program. So this, I'm going to increase the size a bit, is the handler function. As you can see, hello world intent handler for that particular intent. That's essentially how it works, where you sort of define.
We'll remove that one.
Yeah, we removed that one. So we'll be modifying this to match the intent that we created earlier, which was capture birthday. Now, one thing you need to know is whenever someone invokes a skill, right? When they say something like open cakewalk or, open whatever, your skill invocation name, it would go into what is called a launch request. You're getting a request for your skill to be launched. All right. And that is the first conversation a user has with your skill. Now, every skill has a launch request. So you can sort of customize what your skill says the first time a user opens your skill. Most skills would be like, hey, I'm Cakewalk, welcome to the skill, like, tell me about yourself or when's your birthday. So we're going to do exactly that, and we'll see how that changes in the skill. So what you need to know right now is this is the launch request handler. And you're essentially checking that JSON. Remember when I said natural language understanding breaks down anything into an intent and a slot and creates a JSON which is sent to your backend? You're breaking down that JSON and you're looking for the launch request. And here, you're basically saying, if indeed this is the launch request, here's how you handle that particular launch request. As you can see, there's a can handle and a handle function. So you're saying, hey, can you handle this particular intent? Yes, I can. Okay, here's how you handle the function. And what you're doing here essentially is just creating the speech output that Alexa will say out. So let's modify this and say something.
And that's why our first intent is the birthday, because the user already got the kind of command from the Alexa to get the birthday. So the user knows.
Yeah, so that's what we're customizing. So say the user says something like open cakewalk. The skill should say something like, hey, welcome to Cakewalk. When is your birthday? All right, so this is a simple output. And what you're doing here is essentially creating the output for the user. The speech prompt for the user. Now, one thing you need to remember is conversations can end at any point of time. So for instance, if I was asking a skill for the weather, it's what we call a one-shot conversation, where I say, hey, what's the weather? The skill says the weather is 28 degrees, and it's over. Right? But sometimes you need that session to be open for further questions until a certain point is reached. If you want to keep that session open, you need to have this reprompt open. This means that the session is still open for the user to continue speaking to the skill. If you want to end the skill, all you have to do is just comment it out and the session would end right there. But for now, we're asking the user for their birthday, so we need to keep that reprompt open. So let's keep it open. We'll save the skill and deploy it. And again, the great thing is you can test it out immediately on your skill. So we'll test it out. We'll see what happens. Hopefully this works fine.
So this is something that is very noisy. You're talking to your test all the time, or can you type?
Yes. Yeah, you can. You can use the mic here. If you have a device, you can speak to it, or you can also type it out. So if you're in a very quiet office environment, you can just type it out for now.
Yeah.
We, of course, recommend voice testing it because there's a big difference between typing and thing. But for now, let's just type it out.
But it's good that you can type it because sometimes you're in a library or in a cafeteria or something and you don't want to
exactly
talk to your computer all the time. Hello, open cakewalk. Oh fuck, it doesn't work. Hello, open cakewalk. Hello, my birthday is my birthday.
Exactly. So this is what's happened, and I could hear it in my earphones, of course. But Alexa is saying hello, welcome to cakewalk, blah blah blah, and
what is that?
So what you see here, all this JSON that you see here, is the JSON that the NLU sends to your backend. Now, there's a lot of metadata here, which you don't have to worry about too much. There's user ID, etc. What you have to see at the bottom is this, which is the type of request. All right, so I'm just going to do that again. Exit. Yeah. And we'll say open cakewalk. All right, so this is what we just coded. And as you can see in this request type in that JSON, it is a launch request. And that is exactly what we were looking for here, which was a launch request. All right, so that is essentially how it works. So that JSON is sent to your backend. You're parsing that JSON where you're looking for the request type in what is called a request envelope. And you're saying, hey, if it is a launch request, say this.
Great.
And you're keeping the session open. So now, we have just the one intent, which is the capture birthday intent. We need to write a handler for that particular intent. So what I'm going to do is I'm going to copy this because remember we are doing a string compare here.
Exactly.
So it has to be exactly.
Exactly.
I'm going to, cheat a little and just modify the existing intent handler here.
It's not cheating.
It's not cheating. Yeah.
Coding. Okay, it's reutilizing existing code. We do it all the time. Copy paste.
Yeah. So I'm going to call it capture birthday intent handler. And like I said, it has to match the exact intent name. So what's happening is I'm going to paste that exact intent. Yeah. So now what you want to do is typically in this case, the user would give their birthday. So you can choose how you want to reply. You can say, hey, something as simple as,
no, I don't know. Thank you.
Thanks. Yeah. There's something as simple as that, but we'll build upon that.
And what happens now? Because imagine that you say, hey, my birthday is 16th of July. So now the slot, filling of the slot will happen automatically until I don't have the year, the date, and the month. It will not move forward and say thanks. That's right.
That's exactly correct. Because we have kept our dialog delegation to, where is that? Here, to enable auto delegation. By default, it is auto. So until it gets these three pieces of information, it won't go forward and say thanks. Yeah.
So you don't need to build any logic in your backend for that. It just happens.
Exactly. Alexa takes care of all of that.
It's like when you're doing your form validation in your front end, it's something that happens before it goes to your backend. So it just happens in there.
Exactly.
The client developer needs to do all the magic that will validate the dates, the emails, and make sure everything is there. So that's
and once it is, you get it back in your...
Exactly. Good. Thank you. I'm learning a lot.
Okay. So I'll say something like, I was born on July. Now remember, when you're testing your skill out, you don't type 4, the number 4, because typically when you're speaking, it's anyway converted to the full word. So you will always type 4th, or even like 1980 would be NINTEN80, etc. When you're typing it out in the simulator. Because when you're speaking it out, it doesn't matter because there is anyway speech to text recognition. I mean, speech to text conversion. So you don't have to worry about that. Yeah, so this is the dialog delegation that's happening, right? Where if you see my, I forgot to mention the year. And under year, in my speech prompt, one of my speech prompt is, hey, I was born in 2014. What year were you born in?
Okay, so you add some humor to Alexa.
Yeah. So I say something like, okay, 1980.
Nice.
Yeah. So that's what happens. So as you can see here, the name is capture birthday intent. And that's what we are looking at right here.
Good.
So it's actually captured it, yeah.
So now we have this birthday, and where we save it?
Yeah. So basically, right now it's not being saved.
No.
So what we're going to do is we are going to get the what we call a slot value. So first we'll print out the slot value, and then we will actually save it locally using persistence using S3, and we'll explain why. So first I'm going to get the slot values from this.
Because at least when I was doing legs, I will put this on Dynamo or in some kind of persistent storage, like S3 is a good example, but somewhere where you can come back late.
Yeah. All right. So I have written code here, which I'm going to copy paste in the interest of time.
Sure.
So that's what I'm going to do. Okay.
Nice.
And one thing you need to do is also you need to register your handlers every time you create a new intent handler. So basically this is my intent handler, right? So if you scroll to the bottom of the page, yeah, as you can see there's an arrow. Yeah, I am pasting like the handler there basically, right? So this is where this is the starting point of the skill, the entry point of the skill as it says here. And yeah, this is essentially, where you register handlers. So if you create a new handler for an intent, here's where you actually register it. So when that JSON comes to your code, it sort of looks at this and it sees, okay, this particular handler can probably handle this particular intent, and then it goes back to the handler right here. All right. So we have said, const speak output. Yeah. So what we're essentially doing here is I've added an async await. You don't have to worry about that, basically, so that there is no asynchronous things happening. But essentially what you need to know about is here. So if you look at the front end, the JSON, when a user says something like, okay, I was born, July 4th, 1980, there are 3 different slots. So your JSON changes with each of those slots. So that's how it is here. It says slots. The first slot, which is month, the value is July. The slot that is here, the value is 1980. And the slot that is day, the value is 4. Now, all you have to do is extract these values from JSON, which is a simple JSON parse, right? At the end of the day, all this complex stuff is a simple JSON in, JSON out, if you come to think of it. So what I'm doing here is exactly that. Request envelope.request is this entire JSON that you see here. So I'm just parsing out the value of each slot.
Nice.
Yeah. So basically you can see request dot slots dot month dot value is equal to July, and that's exactly what I'm doing here. All right. And once I've got the year, the month, and the date, I'm doing a couple of things which are interesting. So I'm going to save this locally. All right. So
locally in where?
Oh, in my skill. Sorry, I should have maybe rephrased that. So I'm going to save the data in an S3 bucket. As you can see here, every skill if you instantiate a Lambda function, comes with some S3 for you to store data.
Nice.
Now, if you want, again, you can choose to use DynamoDB as well. If you're using hosted skills, you can only use S3 directly through this. All right. But again, say you already have a database that you want to write to, you can use an API to write to that DynamoDB database. Maybe you have your own database in your backend, you can write to that as long as it's API accessible.
Yeah.
But if you want to use the S3 given in this, you can do that as well.
Nice.
All right. And there is a persistence adapter for that, which I'll talk about in a bit. Now, what's happening is when it comes to Alexa, and I'm not sure actually if it's the same with Lex, there are 2 types of session attributes that you can store, which is session for the length of that session. So if I say open cakewalk, talk to the skill, it keeps those session attributes in play till I say exit. And there are things that you want to remember permanently, right? Which are what we call persistent attributes. So here I'm essentially, and Alexa has something called an attributes manager, which sort of helps you handle this. So here I'm essentially creating a new variable called birthday attributes with both year, month, and day.
Yeah.
And I am saving that using my attributes manager. Right? This is what I'm doing. I'm setting it and then saving it. So this saves it to my S3.
Okay, that's simple.
Yeah. So that the next time, say I quit the skill and I come back to the skill, say 3 days later, it would still actually remember, the birthday that I'd saved.
And the things in S3 are managed in a way that even for the right user, it will pick the right attributes. So when you load it, it will know.
Yeah. So right now we're sort of assuming that there's one user using a device, but there is also something called a voice ID, which, if I'm not mistaken, it's in beta for developers, right? So suppose I'm using the skill and I say my birthday is so-and-so, but then the next time my wife comes and uses the same skill and our voice ID is obviously different, you can customize it for the two. But for now, we're sort of keeping things simple and assuming one user is using a device. So if someone else asks, it will probably tell your birthday, but we're keeping it simple for now. Okay, so that's what we've done. Now, this is essentially using a built-in adapter that, again, sort of Alexa offers using S3. To do that, you have to add a couple of packages internally, though. So we need to add something in the package.json, which essentially references that we're using an S3 adapter. Again, there is an adapter that makes it easy for us to store data in S3. You don't have to, create an API, write to that API and all of that. The adapter does that automatically for you. So if you open your package.json file, you can see this is the default. So I can change this to Cakewalk. And I can add a dependency here, which is the S3 persistence adapter. I'm just copying that.
So that's typical Node.js.
Exactly, yeah. It's typical Node.js. So I've added this persistence adapter so that I can now talk to my S3 bucket, which is provided for me, and save data there.
Do you need to import that library or something in your index.js?
No, I don't need to, because the persistent adapter is there. In the sense, I don't need to import it, but I have defined my persistence adapter.
You need to require it,
Yes, I need to require it.
That's what I was meaning.
Okay. And that's pretty much it. But I also add my persistence adapter to my exports.handler here, which references the bucket that it stores in. And it gets that from an environment variable, so you don't have to, bother about.
And where you get this name of the environment variable?
Yeah, so you can just leave it as S3 underscore persistence under bucket, which automatically gets the environment variable used in the S3 instance right here. So you can even click on it and it will show you the S3 bucket that has been instantiated just for that particular skill. So as you can see right now, there's nothing because we've not written anything to it. Yeah, you can see media and deployment completely empty, but essentially that's what it is,
Nice.
Okay, cool. So let us save and deploy this and see how it goes. Also, good practice is to always, once you've tested, to exit the skill, because sometimes the session's open and it'll just throw errors.
And how you do that with voice? Do you say exit as well?
Yeah, you can say exit, cancel, stop, and things like that, and it would do that. All right, so my skill is deploying.
So much code. How many lines there is that? And that's
all of this code, all of this code is there on GitHub, and we'll be putting down the links.
And most of it is generated by you when you are.
It's all by the Alexa team.
Yeah, exactly. So it's not something that you really need to type.
Yes, you can just copy paste all of it.
Exactly.
Okay, so essentially we are in a capture birthday intent handler, and like I said, we have saved the persistent attributes, and now we're using an S3 persistent adapter to essentially save the data. So what's happening is, if you look at, we have created another launch request handler right here, which essentially what this does is it looks at a launch request, which is again very similar to the launch request that we have written here, but it also looks at if you've used the skill before and if your birthday has already been saved. That's the difference. Yeah, so essentially the first time a user logs into the skill, it's like, hey, welcome to the skill, when's your birthday? The second time onwards, because once the user gives their birthday is saved in an S3 bucket, that data is saved right there. So now the second time the user logs in, you don't want to ask them their birthday again. Don't want to say, hey, when's your birthday? You would rather just say, hey, there are like 100 days left for your 28th birthday. All right. So what you're essentially doing is you're looking for, okay, is this a type launch request? Yes. And do you have a year, month, and date already stored? And you're essentially getting that from the attributes manager that I had explained earlier. And you're saying, okay, if there is some data in this, that means that the user has already used the skill, which means they've already given their birthday. So I don't need to ask them their birthday again. And basically you pick out the year, date, and month after that. Right now, we haven't written the code to get the birthday and make the calculation again for the number of days left, which we will do soon. But what we're going to do is welcome back. There are X more days until your Y birthday. So let's try that out. Open. Yeah. All right. So.
Yeah. There it is.
Yeah. So as you can see, the launch request is still, the type is
the same.
Launch request, the intent. Yeah. So it goes to this particular handler and the launch request, and it looks for whether you have the year, month, and date, which we had given earlier. Now, you might have a question as saying, hey, how does Alexa know the difference if, because you've said request.type is launch request here, or request.type is launch request here as well. Now, remember earlier we at the bottom had registered our handlers. Now, this order actually matters.
Okay.
So if it is a launch request handler, or any intent, basically, it would look in exactly this order. So we first look here where, there are two checks, right? There is a check. Is that?
For the launch request text and for the years and month and date.
Exactly. So suppose it's the first time the user is logged in, where we don't have the month, date, and year. That fails, and then it goes back and looks at launch request handler again, where
it's only one check. So if you put it first, then it will always hit there.
Exactly. Yeah. So that order actually matters, and you can use this to make your skill a lot more intuitive by using this particular order in this export.
So that's a good tip, because I was not thinking about it.
Cool. So we're almost done with the skill. Now, all that is left to do basically is to essentially, figure out write the logic for calculating the number of dates, the number of days to your birthday. And one interesting way you can do that is there's something called the customer profile API. Now, every user has, of course, their first name, last name, email ID, time zone, and some other piece of customer information that you need not necessarily ask the user for, but use an API that the user has to give their consent to, of course, to get these pieces of information. So what we're going to do in this particular case, we will use that particular API. Again, I'm just going to copy code. All of this code is available in the link given below, so don't worry about it. So I am just going to do that right now. So I've just copied some code, which essentially gets the user's time zone. So what you need to know is that there is a built-in API to get that customer profile information, and that's exactly what I'm doing here. Think of the service client factory as something that you would use to build certain things. The first thing is every device has its own unique device ID, which you can use to identify a piece of information. So using that service client factory, you can figure out a few things. And you can also get the device ID from that earlier JSON from that request envelope. Essentially, you can use this particular line, which is a service client to get piece of information. So you can get things like user time zone and email ID and things like that. You don't have to worry too much about the code here. All we're doing is just getting...
Where is the place to find the documentation for all this thing?
Oh yeah, that's fairly simple. There is Alexa. I can just look it up actually. Documentation. There is developer.amazon.com where all the APIs, everything is just mentioned here. So look specifically for the Alexa skills kit where all of what we have discussed is there, including like the API.
Alexa API, and that's the one we are calling now.
Yes, you can look for the customer profile API. Yeah. And this is a blog post, of course, but here we go. Here's documentation as well. So you don't have to worry too much about it.
Just to know, because sometimes it's kind of you follow the tutorial, but you want to do something else. So it's good to know where the docs are.
Yeah. And you don't have to worry too much about this logic. It's essentially taking your birthday and the current date, just doing some subtraction to figure out, how old you are or how many days until your next birthday. Just some simple logic.
You will do in school.
Yeah, this is simple stuff. I'm going to build and deploy this code. Essentially, what this means is, yeah, there's some rounding off, etc. But what this means is now I can get to know exactly how many days until my next birthday once this code has been built. It has. Okay, let's try this. We will say open this clock. Yeah.
Oh. Soon is your birthday. Are you prepared?
Yeah. And I'm not 40 years old as well. This is just like a fake.
Yeah.
I'm a lot younger.
Yeah.
Yeah. So this is what happened essentially. And as you can see here, it still goes. It is a launch request because all I've said is open followed by the skill invocation name. And yeah, all of that that thing is happening. So what's essentially happening, and Marcia, if you don't mind, I'll go through the entire flow again.
Yeah, sure.
So when I said that, it looked at this particular handler, which is birthday launch request handler. And there it essentially looks at, yeah, this one. It says, okay, look at session attributes, which we already have, which is our date. Is it type launch request? And do you have the date, month, and year, which we do? And then it goes into this. Now, we can open that S3 bucket to actually see how that data is stored. And if you want to maybe test out different ways, yeah, I just go here. And this is the file that's actually stored. So I can just download the file, yeah.
So basically, Alexa is creating like an AWS account every time you are creating an Alexa account.
Yes, kind of. So I can maybe just choose like a visual. Okay, so I can just open this file in like a VS Code or something like that. Yeah. So that file that I just downloaded, it's a simple TXT file which has these attributes. You can see here we saved as 1980, and we saved July 10th as, which is not my real birthday, but I don't know why I chose that. But you can see that's how it's stored here. Essentially, that's how it works.
So for each user using your cloud application, you will have one file in your S3 bucket.
Yes.
So if you have 100,000 users, you will have 100,000 files with one line, basically, in this case.
Yeah. And of course, if you have like that bigger skill, typically you wouldn't be using this. You would be maybe using a Lambda function in your AWS account with the DynamoDB integration.
Sometimes you don't want to overcomplicate it, and I think that's something I talk quite a lot about, like why to over-engineer something. So if you're doing some app as simple as this, why to add a Dynamo with all the complexity of Dynamo file?
Yeah,
can do the job. So, but yeah, sure, you could add Dynamo, and I think it's really good that you can use your ARN for Lambda and then take advantage of everything.
Yeah. In fact, the SDK has not the hosted instance, but if you create like a Lambda function for your backend, the SDK has connectors to DynamoDB as well. So it's pretty simple to get that set up too. So like creating a new table is just like a one line of code,
nice.
and you can use session attributes to write to Dynamo databases as well. So it's fairly simple.
That's really cool. Now we have a whole flow on building our application, our very simple application. But I think with this we have enough power to build a skill, and also with the integration that you mentioned with Lambda and Dynamo, everything is in the documentation. So people, if they want to dig more, they can find out things. And that's like most of the things that you need to do in order to build a Lambda skill. What is a next good step to continue learning if they want to go? And what you recommend? What kind of?
Yeah, so there are two things, of course. One is one thing I tell everyone is I think coding is something that all of us are good at. We will figure it out. And I've done a lot of workshops, and the code, people just get it like that. Pay a good amount of attention to the voice design part of things, where do a lot of manual testing, get your users, your friends, your colleagues to test out your skill manually, and pay a lot of attention to that part, because that would also affect the code. And I think a big difference, again, is a lot of people start with the code and then do voice design. But when it comes to a conversational interface, you want to do your voice design first and then do code, because that dictates how you're coding.
Is there some good book on voice design or blog post or something that you can give as a pointer?
Yeah. In terms of books, I don't know if there are too much because it's so new, but there's a lot of content created by the Alexa team. I want you to look up something called situational design. It's a framework on how to get started with voice design. It's very useful. It gives you a good way of thinking and how to use teams and how to, build voice design first and come up with that paradigm and then start coding.
Cool.
So second piece of advice I'd give is, of course, hosted skills is good to get started, but soon get familiar with the CLI. There is an Alexa CLI that works with the AWS CLI.
Oh.
So you can get started and then, you can, of course, Marcia, you're an expert with this, but you can, do the CI/CD bit and, check in your front end and back end code and write scripts for that and, do things at scale, work in a team.
That's nice.
Like
so
that.
You could not use that web browser to work with your Lambda function. You could use Visual Studio Code as we are all used to.
Exactly, yeah. And you can just check in code into, your AWS Lambda function. And you can also build like the front end parts, which would check into developer.amazon.com.
Yeah.
So I do like, ask, deploy, and followed by like cakewalk, whatever. It would deploy the front end, all my utterances intents to dev.amazon.com and my back end to say amazon.com,
Nice.
aws.amazon.com.
That's really cool. So those are kind of good pointers for people if they want to continue their learning. It's not just going to and typing code in the browser, but there is quite a lot of things that can be do. Mm-hmm. And where people can find you? What is your favorite place to hang out in the internet?
Oh yeah, yeah. So I'm on LinkedIn and Twitter. You can look at Sohan Maheshwar on LinkedIn or Sohan Maheshwar on Twitter. Links down below. And I'd love to hear the sort of conversational experiences y'all are building. If you get stuck or if you need any help, feel free to reach out to me and I'm always here to help.
Yes.
And I'd love to see what you're building.
Cool. Thank you very much, Sohan, for your time and all the knowledge that you have shown us today. I'm quite excited now. I want to build something. And I will leave all the links in the description box. So that's something, it's available for everybody to check out. So thank you. Thank you very much.
Yeah, thanks for having me. Thank you. Bye.
Thank you.
This was the session for today. I hope you like it. If you did, give a big thumbs up. Thumbs ups really help me out. YouTube loves that people give thumbs up, so please do. And you can find all the links for Sohan Talk in the documentation box. They are there, everything. And if I missed something, let me know in the comments. I will be trying to collect those links for you. And that's it. I see you in the next episode of FooBar. Ciao, ciao!